Hello back. I'm here with Cyrille Martraire. It's easier for me to say it in French actually because he is French, I am French, and this is where I get to know Cyril. He founded the Software Crafters Paris community, where my personal journey began. And later, when I moved to Canada, I created the Software Crafters Montreal community, all inspired by Cyril's work. There is another big topic that Cyril is really good at, and this is documentation. And documentation is a difficult topic. Usually it sucks, and in legacy code it sucks even more. If it's present, it's out of date. Cyril has wrote a book, Living Documentation, about that, how to make documentation that doesn't suck. And today in this talk is going to share his expertise in that topic. So without further ado, Cyril, you're up.
Thank you very much, Nicolas and Adi. So yeah, how to make documentation that doesn't suck. That's a big topic. So that's a talk about documentation. But first, I want to talk about termites because why not? So termites build impressive nests in the wild, like this one. And do you think termites draw blueprints to build their nests? Do they draw diagrams? Of course, no, they don't. Actually, we do after the fact when we try to understand how they build these incredible buildings. And these buildings, incredible they are. They are passive cooling buildings. They have vents for breathing, for letting the heat go outside. And they even have gardens, internal gardens to grow food. That's incredible buildings indeed. So how do termites coordinate? How do thousands of termites coordinate to build these masterpieces in the wild? Actually, the phenomenon is called stigmergy, and I learned about it thanks to Michael Feeder. And what is stigmergy? Stigmergy is a very pedantic name, of course, but for something very simple, the termites, they coordinate through the work itself. In other words, through the nest under construction. And so they do that, and they do something more. They also put some chemical markers on top on the work itself so that they can coordinate even better. For instance, if a termite is asking herself, what's hot right now? Where should I go to in priority? Then she could go, or it could go to the places with the most chemical markers on. So, I'm a developer, and I still identify as a developer after 20 years. And this way of working of termites look very similar to the way we work as when we manage code. We developers, actually, in the wild, they also collaborate mostly through the work itself, really, through the conversations, including what you hear like that, random sounds you hear of colleagues working, and of course, a lot through the code itself. And even though we don't like to pretend that much, we are working a lot through the work itself. So, but there at this point, we could say, Cyril, that's not real documentation. That's not what we need. We need real documentation. And, as you say, as Nicolas said in the intro, real documentation sucks. It's so boring. It's so frustrating using tools that are always against you, trying to frustrate you even more. Also, if you are in development, in software development, it's probably because you like coding, and doing documentation purpose tasks is not coding. If you are in software development, probably you like executable stuff that moves, that dynamic behaviors. And documentation usually is not like that. It's more like a dead thing. And you've used a lot of documentation yourself. You try to create some, and very often it ends up obsolete or misleading. No, sorry, this is not basmati ice in this box. So yeah, documentation sucks, but actually traditional documentation sucks. And traditional documentations, nobody wants to maintain that, and for a good reason. Because traditional documentation makes your work slower, not faster. So the title of this session is Leaving Documentation, and the answer is yes. If you're talking about traditional documentation, yeah, sure. Please, let's leave documentation behind and do something else. But still, you could be there and, yeah, but Cyrille, we still need some real documentation. So then I should ask you, why do you need documentation after all? Let's try to find why. So it happens that if you are looking at the way software evolves, making or evolving software is a lot about finding answers to lots of questions. Like if you are not a developer, you could have questions like, hey guys, what's the precise criteria to be VIP in our system? Or do we support this case? I'm not sure, I don't remember. Or I want to introduce this concept into our system, and do we already have something similar somewhere? Or it's these kind of things. And if you are developers, you have a lot more questions indeed, like I have a change to make, where should I add this change? Can I make this field mutable? Or this thing is ugly and sounds useless. Can I remove it safely? Why did they do this stupid thing? Or these kind of things. Can I change it and being compliant with the architecture? All these kinds of questions, lots of questions. And turns out in the economics of changing code, the faster you get the answer to all these questions, the faster you deliver. So it's all about knowledge, knowledge, knowledge. And the faster you get the knowledge, the faster you can deliver and please your customers. So I would at this point, I want to reframe documentation as a form of passing knowledge from people to other people, obviously, but also passing knowledge from, so it's a matter of transmission, but also passing knowledge to other people to make knowledge accessible when it wasn't accessible to other people, like typically passing developer stuff to non-developer people who would like to understand a little bit what we're doing. It's also passing knowledge from now to the future. And so it's more like memory, recording, preservation of knowledge. And passing knowledge is also for the future in terms of compliance. Somebody else will have to verify that we've done the things right and the right way. So if you look at the documentation as a way of passing knowledge, you actually need something special every time you have knowledge that is useful in the long run, that is useful for a large audience, or that is useful because if you don't know it, you run big risks because it's critical. Apart from that, if you are not in any of these cases, you could wonder if you really need to do something special with the knowledge. And perhaps doing something special with this knowledge would be just waste. So at this point, I'm proposing to you that the ideal situation when it comes to documentation is a case where everyone would have access to just enough knowledge, not everything, just enough knowledge, just in time, knowledge that you can trust and do something based on it without doing a mistake. And all this as a driver to accelerate software delivery. And this leads to the four key principles of leading documentation in my book. So of course, documentation, everything, all this knowledge that you get has to be reliable so that you can make decisions on it and be right and be relevant. But it has to be low effort. Ideally, you should do nothing special about it. But if you have to do something, it has to be a very little effort. And it should bring some additional benefits at the same time. So it should be insightful, like doing something for documentation purposes should help as well, should help you get more insights and feedback on the quality of what you're doing. For instance, that's a typical example. And all this, of course, has to be collaborative or should foster collaboration. So if I have to do something that would oppose collaboration, it would not be a good idea. So this idea, they could translate in this kind of statements. we embrace continuous change. That's the point with traditional documentation. It doesn't embrace continuous change. It's supposed to document something that's finished. But right now, I'm not living in a world of software being finished. Never. And the same for you. So you don't have time for documentation, of course. Nobody has time for documentation. And so we want solutions that don't take a lot of time from us. So back to Stigmergy, but this time for developers. Stigmergy for us, for developers, is considering the idea that most of the knowledge that we need is already there somewhere in the system, even if it's not obvious, and even if there are a lot of problems with this knowledge. So that's one thing. And the other thing is this knowledge is never complete by itself. It may be 90%, 95%, 99% complete, but it's never 100% complete. We have to add something more. We have to add our own chemical markers. And we would call that, or I would call that in the book, augmenting the code with markers to make it knowledge complete. Something like that. So basically, these ideas are the thing at the bottom: augmented code, ready-made documentation, etc. And we're gonna look at these concrete examples very soon. But it's all in the book, so shameless plug. Buy my book. It's a thick book, 408 pages of prose on how not to write prose. How ironic it is. If you get the book, and if we have the opportunity to meet each other, I'll be very happy to sign it, of course. So let's open the box. What kind of living documentation techniques do we have? The first one is, number one, maybe get rid of it. Maybe no documentation, because many times we can do better. And the default approach to documentation, I believe, should be nothing special about documentation, just working together, for instance, or agreeing to a standard. And so I was happy to see that Esther, just in the talk before, she talked about standards and how standards remove the cognitive load because it's decisions already taken, for instance. These very powerful ideas. But a standard is also something in your own context. It's something that everybody is supposed to know already. So of course you are not supposed to document again and again and again the standards everywhere you are using them. So that's an example of an approach of reducing the need for documentation. Another example would be conversations and everything, more generally, everything working collectively. Collective working solo is definitely not a documentation approach, but as soon as you work with more people, even being in the same place and overhearing things is already a little bit of knowledge sharing. Pair programming goes further and more programming even further. Coffee machine chat. In my life, I've seen a lot of usefulness for this coffee machine chats. More official forms of like event storming sessions or live my life sessions are all primarily knowledge pacing activities, of course. And a little kitty there, just to conclude that just with that, you can go a long road, you can go very far in sharing knowledge just with these approaches. Of course, it's not enough. You have to go somewhere, you have to go further for some kind of knowledge, as we've seen before, long run knowledge, large audience knowledge, critical knowledge. And for this, you need something more structured. And in this case, the first thing to keep in mind is this number 2 point. Most knowledge is already there. It just wants to escape. It just wants to be useful. It just wants it to be made into something valuable. How do we do that? You look everywhere in the system in most general sense, the code, of course, but the test, the types in your type systems, in Java, C#, whatever, the annotations, the naming of your identifiers, every pattern you use, Even the folders and the way you structure the folders, they tell a lot of story, these folders, the way you've done them. If you use GitHub, the organization of GitHub, the way you are using these things. If you use Maven or NuGet, the way the repositories are split, the code bases are split, the branches, the commit history, even the way you use tools and the memory of tools. It's all about knowledge that typically we don't use, we don't mine. And of course, there's also the working system at runtime and all the traces that the working systems can give you. It's been known for a long time that the debugger is a documentation mechanism. So most of the knowledge is already there, true. Not all, but most of it is already there. But there's a lot of problems anyway. You may not know where to find it. It may be very obfuscated. Think about the legacy system. It may be non-accessible for non-developer, for instance, or it may be fragmented. It may be split in so many places that it's awful. It's a lot of work to extract it. It's a lot of work for people. So it could be not so much work for a tool, for a machine. But at this point, I just want you to remember that the key idea of living documentation, and one big idea is knowledge is already there. It just wants to break free. And so if you remember the Queen song, I want to break free, think now it's in your head. Now you won't ever remember, and you won't ever forget to think about this idea. The knowledge, most of the knowledge is already somewhere in your system, which means you don't have to tell it again. That's what it means. Concrete example. If you ask yourself, what's the language of the domain? What's the ubiquitous language of the domain, as we would say in domain-driven design? You could try something. You could first try something like a word cloud on your domain layer in your system. And if you find something like that, you could say, it's talking about merchant, basket, fuel. Maybe that's something to do with cars and fleet management or something like that. Of course, if you find that, it gives you an insight. The insight is that maybe your design sucks big time, and the knowledge of the domain is not in your code. Bad news, sorry. But we could go further. If you want to know the language of your domain, the reference, the source of truth, this knowledge is already there. It's already there in your code. If you've done a good job of, for example, if you've done careful domain-driven design kind of approach when writing your code is the source of truth of the language of your domain. In which case, you may want to extract the knowledge out of the code and to make it more accessible to non-developers in the form of a glossary. And in this glossary, you will have multiple chapters, one by subdomain. So bounded context, if you don't know bounded context, just you could understand them as modules of the domain, modules of the system. But the rename is bounded context there. It's from domain-driven design, of course. So in my glossary, in each chapter, for each subdomain, for each bounded context, I will have a description of what is this subdomain about. And then I will have the list of all the concepts of this domain. But because there are too many concepts, it's very powerful for the readers to have a summary of the most important ones, the core concepts. There should be like 5, 7, 8, no more than that. And these are the concepts that form the backbone of my domain, of my subdomain. And for each of them, you then have the description of what they are, just like traditional Java doc. And the benefits of having a glossary, yes, but it's a living glossary, is that anytime you change the code, so pretty much all the time, every time you add, delete, rename, or move something in your code, you can have a new glossary always in sync with the latest changes, and it just takes half a millisecond to generate. Of course, you don't have to create a glossary in Markdown or text. You can do them in Excel. That's a real example I've been using long ago in 2011, I was sending that to my customers. Whenever they would ask, Spring generate, and I would send the new glossary. So how, you could ask yourself, how do I know, how do my generator of my living glossary knows that these three particular concepts are more important than the other? The answer is my generator doesn't know. I have to tell the code that this particular concept is something for. And I do that again by extending Java with annotations, and which is precisely a way to augment the knowledge that is already there with the little bit that was not already there. So typically, if I come back to my code, you see that here the naming and the structuring is already very clear. You see the packages on the left, and these packages, there's one package for each bandit context. Very simple. In other words, my bandit contexts are visibly there implicitly. So if you know bandit context, if you know that I'm doing one package by bandit context, it be almost explicit. But if you don't know, it's not written anywhere. So it's still implicit. So how can I make it explicit? How can I turn this implicit into explicit? And that's what I want to do as a part of my documentation approach. So I will, you know the answer, I will just extend Java with custom annotations like bandit context annotation, some documentation for the annotation itself, and then I can put this annotation like a tag on my package. Because you know in Java you can put annotations on packages. And because it's a package, it has a comment, java.comment, comment, and which is precisely the comment that I would see at the beginning of my glossary for this chapter on this part of the subdomain. That's all. So you see very simple things, very simple mechanisms, nothing fancy indeed, just common things from your language, from your technology that you already have, but additional benefits like real-time living glossary. The thing is, and there's additional benefits of doing that. Every time you make things explicit in your code, like with annotation, your fellow developers, your colleagues, whenever they would work there, they would see, oh, what's that? That's an annotation I've never seen before. Oh, there's a tooltip. Boom. Oh, there's a link in the tooltip. I must click on the link. And boom. Ta-da! Now you just send coworkers to reading Martin Fowler, the blog of Martin Fowler, which is always a good thing, right? Martin Fowler explains things better than pretty much everyone else. And even if they would read the blog and say, oh, I'm not sure I understand everything. Who's put this annotation there? Oh, it's Nicolas. Oh, Nicolas, please, can you help me explain? Can you explain that to me? And now you see that now Adi or Nicolas will have to explain bandit context to someone who is asking for it. That's embedded learning on the job, and it's far, far better than preaching. Don't preach. Don't say to everybody, you should know about bandit context, blah, blah, blah. But if you, based on the curiosity, they ask you, that's nice. So in practice, how to do this knowledge augmentation thing? But then again, we want to be lazy and low effort. Most of the thing you are doing, most of the stuff you are doing, unless it's very esoteric or very strange things, in which case maybe you should not do it. But most of the things useful that you are doing are already explained somewhere in the literature, and probably it's already explained very well by someone like Martin Fowler or other people like that. So basically, this idea is most knowledge that is not in your system is already there anyway, somewhere else in the literature. So don't write prose again and again and again. Just link to somewhere it's already written and well written. So if you are doing something like it's a front service that is something on the back end, but it's for the front end. So if you know that, or if you find out, or if your colleagues tell you that it's called backend for front end, then you just have to go. It's some human talked about it and coin the name. Then you're done. You just have to say it's called the backend for front end. Here's the link, and I'm done. If you are rewriting a part of an application bit by bit, it's called a Strangler application. Martin Fowler wrote about it. That's done. If you are using an identifier so that you can correlate back the answers to a question, the response to a query, is called a correlation ID, and Gregor Hoppe talked about it in 2000 long ago. Most of what you are doing is already there somewhere, and so rather than writing prose, don't do it. Instead, go for a search, for a quest of finding how it's called in the literature, and you just have to reference it. And once you found the typical pattern name in the literature, most of the things are documented as patterns. You just have to find a way to add this information to your system using annotations in Java or whatever kind of tags in other systems. In GitHub, you will do tag. If it's middleware, you would use the extension mechanisms that's supposed to be used to extend this middleware. If you are using MAQP, you may have a look at how to put some annotations or tags or payload or side remarks into the AMQP messages, for instance. And that's it. So concrete example now. If developers are asking questions like, what's the architecture in place so that I don't break it by mistake? One possible solution would be to introduce a living diagram this time. Let's take a favorite of mine, the famous popular hexagonal architecture. You know, it's an architecture that said that you have a domain model inside and everything infrastructure outside. So if you've done that initially, the design is already there. But again, it's already there implicitly. It just relies on the naming convention. So you could go, if you rely on naming convention, so like something like this, something that domain is supposed to be the inside of the hexagonal architecture, and everything else is supposed to be the outside. Making this explicit means either document the naming convention somewhere, or do something else to make it explicit, like maybe again annotations, because we are still in Java. Here, for instance, using annotations, it's obvious. There's a word hexagonal architecture visibly in the tag, and now we can see that everything .leasing is the domain model, and everything adapters is supposed to be the adapters. The good thing with making the knowledge explicit by augmenting it is that tools can now use it. These tools can now use the knowledge to do stuff on your behalf. And for instance, you could generate a diagram. So that's something, actually, if you look at my GitHub, look for something living documentation, you would see examples of parsers to generate glossaries and diagrams like that. You would see that the code is quite short and quite simple. It's not beautiful code. It's something more hacked, but still, it's like 1-2 pages of Java code. It's not much. It's something that you can create each time for your own context, because it's always different. And for instance, here we just parse the code, look for the dependencies and nothing else, and generate the diagram like this. So you see, it's not really hexagonal. It's not pretty, but you can see that there's an inside with the domain stuff and the domain language inside. And by the way, you can see that in-memory lexicon may not be the best name for this thing inside. It's obvious on the diagram. The other good thing is that this diagram, you can generate it. So here, the generated diagram is just a kind of, we are hacking the unit test framework to run them. Just a hack and another hack again. So here, for instance, we have an interface called sentiment history with one method. And we generate, so we parse the code, we generate the code, and it generates a list of text entries that are used by the tool GraphViz. It's a free tool. Also exists in JS if you want to put it into a page. And from this list of stuff, you can generate the diagram. So now if I refactor, if I rename this interface, and if I run the diagram again, trend, boom, let's have a look at it. You can see that at the beginning, at the bottom, trend, now it's called trend in my diagram. So you see, you can have milliseconds, you can be in sync in milliseconds with every change you are doing when it comes to your diagrams. But there are traps. There are some dangers doing that anyway, so please beware. You have to curate aggressively everything you show. Otherwise, you end up with diagrams like that, which of course have absolutely no value. So whenever you are creating a diagram, start on paper. I would suggest you start by hand what I want. And make sure that you tell one story and one single story. One diagram, one purpose, one single purpose by diagram. If you are doing hexagonal architecture, the purpose is usually about dependencies. You know that hexagonal architecture is supposed to have the dependencies from the outside to the inside, never the other way around. So now if you generate your diagram and you see something like that, you see, oops. So now don't fix the diagram. Of course, fix the code, run the diagram again, and make sure that it's fixed. So talking about this case, the very code generating the diagrams could be used as well to raise warnings or failing the build. In which case, you could just as well use another technique of leaving documentation, which I called enforced guidelines. The idea is that why creating something documentation-ish and expect people to go look at it when you could do the other way around, have knowledge that would go after the people when they need it. Typically when they fail something, now it's a proof that now they need to know about it. So rather than asking, is my change compliant with the architecture, just make the other way around. Let them do things, and if it's not compliant, boom, the tools will tell them. So that's something that have been quite theoretical for a long time, but increasingly we have more tools to help with that. So for instance, ArcUnit in Java is a very powerful assertion library that, and with it, you can write unit tests that describe a lot of your architecture in the small, inside the microservice or inside the module kind of architecture. It's very, very expressive, and that's the best documentation ever. Nobody has to read that unless you break the rule. That's the best. So it's kind of reality check. You look in the mirror and see if what you intended to do is actually what you've done. So my wife in the book, there are very cute illustrations like that done by my wife. I love these pictures. So your tools are like the little cops. Hey, you said that you intended to create an hexagonal architecture, but actually I found a rock dependency. So now what do? You fix it, and maybe you offer a coffee for everyone. So all these ideas, I'm not the only one, of course, to talk about that. Increasingly, more and more people are playing with things, and for instance, Simon Brown is increasingly doing things like that as well. And it's good news. So at this point, I've been talking a lot about stuff for developers, stuff for the technical aspects, because it's the new part of this book. But the part that you probably know is the part, how do I document the business behaviors? And you know the answer. It's all about behavior-driven development. You know the story. In little feature files, you write down the intent, you write down the concrete examples. And while you're with that, you can just put everything else inside the same file, and so that everything is on the same place, and and you can replace all your traditional specifications with this approach. Yeah, really. So at this point, I just want to mention one thing. With BDD, there's something else in living documentation, in living glossary, living diagram. The idea was that the knowledge was already there, and we would extract it from this place to use it somewhere else in some other form. With BDD, there's something different. There's a code doing the behavior, and on top of it, we describe the behavior again in the scenario. So it's redundant, and it's redundant because we don't have anything better right now. So the risk, of course, with redundancy is that what if one side changes and not the other? That's dangerous. And that's the beauty of Cucumber, SpecFlow, and these tools. They act like reconciliation mechanisms to make sure that both sides match at all time. And so if you cannot get the knowledge from one single place, you just have to make sure that if the knowledge is redundant at two places, make sure that you have an automated mechanism to make sure they match. That's all, but that's an important thing. So living documentation, so the name actually comes from BDD and Gocoedic book. By the way, if you are doing living documentation like that, you can extend your scenarios with tags. And if you carefully craft the taxonomy of tags, you can improve big time the quality of the documentation based on your scenarios. For instance, if you use pickles on top of it, and you can use the search engine to look by feature names, of course, but you can also look for navigate by tag, which is even better. All right, and note, by the way, that the chapters of these behaviors, they are just the folders of your feature files. So the tools relies on the knowledge that is already there in the way you organize your folder. So with this kind of approach, you can go very far, and you can also completely replace specifications in many cases, including having the big PDF at the end, if that's what your company requires. And my friend Arnaud Loyer created a tool called Tzatziki, because it's a recipe of cucumber that can give you a big PDF that is completely compliant to the Big Bang, for instance, kind of expectations. So at this point, I could go on and go on and go on and talk about and mention that, of course, the better you do code and the quality of code and the expressivity of code and the tests is a big part of the living documentation approach. Of course, it's obvious. Traditional commands are shameful. Typically, you can do better. You should refactor them, something more like that. You can get rid of most of the traditional commands. I want to mention something else. If you, with a living documentation approach, you may still have some document in prose, but they can only be used for knowledge that is stable, like stable forever. If these documents contains things that can age, it should be removed. For instance, the project manager name there and the project name, Phoenix, is not something that will last for a long time. It should not be in this document. This document should only be about, for instance, the intent of the full product. So a key question when choosing your techniques is how frequently does it change? That's a key technique. If it never changes, then you can use a Word document if you like. If it changes a lot, you need something more living. Something that doesn't change much is everything decision log, everything big architectural decisions. And for that, you may use simple text files, markdown files, for instance, in the simple folder at the root of your code base. And basically the structure is, in this context, with these problems we had to solve, we had these options and we chose this decision because this trade-off, kind of. So something like that. It's like this short is that this long. And it can be something, so it has to be short. And the idea is that anytime someone in the next time in maybe in 6 months, if somebody reviews these decisions, they would see this and all right, so this should be reconsidered as soon as we can. Now we can. Let's reconsider it. And now we can change the architecture. We have many other ideas like plain text diagrams. Many of the diagrams you do on whiteboard, you can just forget them once you took the decision. But if you need to make them live longer, you can turn them into text files and generate diagrams out of it. And plain text is very nice to live with. Living guided tour, missing a word. This idea is another one is, so there are many other ideas and you can invent your own. Typically, a lot of developers, when I do coaching, for instance, I see a lot of developers, when they start something new, they first look for where's the place where I could find something similar that I could copy to go faster. The drama, of course, is if they find some place that is ugly, they would take the inspiration from something ugly. So as a team, you could decide to put some markers. If this place are very good examples of what we want more. You could do the reverse, by the way. This place is what we want less. Ugly. And so, for instance, if I'm looking for a place to start, I could just ask in my IDE, I could start where show me all the exemplary parts and look for them, no more than 5 maybe, and oh, this one is closest to what I want. I start from there. So it's more like it's very poor man scaffolding, like, or templating. This idea is very similar to, so another idea is the guided tour. This one I took from Simon Brown. In his book, he kind of uses the metaphor of a system, comparing a system to a city that you visit. If you want to discover a city in 2 hours, you take a guided tour. And the same idea, if you want to discover a system in very quickly, you could have a guided tour for the people. So typically, this means a guided tour in the mountain is you follow the signs and you go through a nice place. In a system, you could again mark some places and you could go through a complete conversation from the listener, from the bus to the calculation and back to the storage or whatever. And you could generate the guided tour or have it built in your IDE just at a click of a little search on the annotation, for instance. So I'm about to finish, and I just want to mention a couple of other examples. You could generate the system diagram out of your system plus some augmentation things. If you go event sourcing, you could generate a lot out of your scenarios. You could generate the diagrams out of your scenarios or test scenarios. You could document the data lineage. It's not just Java code that you can extend. You can extend everything, including console. If you use console for discovering microservices, you could add tags on the components in console, so that you can query console. If something wrong, you could say, oh, I want every component, every services that is B2C, and it gives you everything that is B2C, or everything that is B2C and that talks about leasing, and it gives you that. All these ideas you can extend there. And if you have a hard time doing leasing documentation, that's the feedback that maybe there's something wrong in your system. Maybe you are relying too much on programming by coincidence. Blang, blang, blang. Oh, it works. Oh, I stop there. No, that's not the way we want to work. More in conclusion, if you know what you're doing, it's already half documented. And if it's simpler, it's already documented already. So in closing, buy my book, of course, and documentation, actually everything, everywhere can be used as a documentation. And so that we can, and with these approaches I've shown you, I hope that we can make documentation fun again and be leaving traditional documentations to embrace living documentation. Thank you very much. And if you have any questions.
That's really nice. There was so many things to unpack in this, and I recommend people to indeed get the book, so you'll have more time to dig into all of what Cyrille has presented here. A lot of tools, a lot of approaches. Basically, there is a way to generate your documentation from the source of truth, which is the code, and many options I think you have now to make things better. And I like how it resonates with the interior design talk, and also foreshadowing the Jean's talk on hexagonal architecture in particular. Everything is connected.
We are big fans.
There is one question, and then we'll take a break. So one question, I think you answered it, but I'm going to ask it anyway. Is there any standardization open source for the glossary annotation, or do you need to define your own per project?
I tried, to be honest, one answer is that I tried for a decade before I decided to give up and turn that into a book instead, because every client, every context, every company I work for was different, and was so different that there was no hope of having a standard tool. Like almost 10 years later, now it's the standards have improved and it's probably doable again. And actually people from, I think, some German people are working on something, on standard set of annotations. We've been in touch each other. Some companies are doing things, but right now it's all custom. So if you want that, you have to do your own based on, for instance, my GitHub. But maybe now increasingly we could try to do some standard frameworks on top of it. But the short answer is that usually some companies want runtime annotation, some want class time annotation, some want different types of retention, some want hexagonal architecture, but they want to be named after port and adapters. Or it's so different based on every place that it's very hard to standardize.
Yeah, I agree. And you're showing that it's not that hard to build yourself. So
it's not that hard to build yourself. Yeah.
And okay, quick last one. I think it's interesting. How do you avoid code pollution? In the sense that there will be too much documentation annotation that it will become a mess. Does that ever happen to you?
Mm-hmm. No. One way is to, so out of, there are many ideas, but one of them is also to declare your style. For instance, if you start a new module and you decide that everything should be immutable inside, you can just put immutable annotation on top of the module, or just say that I want to go in a functional style there, functional FP style there, and you've done it, you've played it all. It's implicitly, obviously, it's functional means immutable. And now you can you only have to put a mutable tag on the few places where you have to have some. So you can work like that by exception. That's the most powerful technique, of course. These kind of things, yeah.
Okay. Yeah, as a way to reduce the amount of comments you need in the code. Nice. Yes. If people want to ask more questions, you can do that on Twitter, I guess is the best way to reach you.
Oh yeah, you're welcome. And by the way, you actually, with annotation, you remove the pollution, because usually this pollution is already there. It's in your class names, like nanana service.
That's right. And as Esther Daniel said, by adding some, you will actually reduce, even though you're writing more code, you are making things simpler. So it feels like there is less code to read if you're doing it right.
And now you can have ArcUnit rules to check, and ArcUnit can use these annotations to put rules on top of them. So yeah, it's all a system. Thank you very much for the invitation and your questions.
Thank you, and we'll see each other in 10 minutes with Anna Dr. Anna Clarkson talk, following up on living documentation. All right, see you there.